I'm going to do some of these problems multiple ways. So for the first one, if we were going to use elimination, I would choose to eliminate the y's because one is positive, one's negative, and it's simple enough to just multiply. So I'm going to do twice row 1 plus row 2. When we do that, we get 4x minus 2y equals 14. Row 2 doesn't change. So when we add them together, we get 7x equals 21. So then x equals 3. Once we get x equals 3, we can plug this back in. So we have 2 times 3 minus y equals 7. And then this is 6. So if I subtract 6 from both sides, I get negative y equals positive 1. So then, let's see, so then if I do that, then I get y equals 1. So final answer should be 3, 1. All right, so if we check, we get 6 minus 1 is 7, good, and we get 9. Oops, sorry, this is negative 1. See, good thing I checked. Yep, and then 6 minus a negative 1 is positive 7, and then here we get 9 minus 2 is 7. So 3, negative 1 works. Okay, so that's if we use the elimination method. Okay, if you're using substitution, you'd probably solve this guy. So you get y, if I move this over, y is 2x minus 7. And then you would have 3x plus 2 times y equals 7. So you get 3x plus 4x minus 14 equals 7. So 7x, add 14 to the other side. And then 7x equals 21. Then we get x equals 3, and then you would just go ahead and solve the same way over here, okay? And then for number 2, for this one, I would use substitution, but let's say you decided you were going to use elimination, and if you were using elimination, we would want to get the x's on one side, so negative x plus y equals negative 13, and what you would do then is row 1 plus 4 row 2. So we get 4x plus 5y equals 7. And then you would have negative 4x plus 4y equals negative 52. Add those two guys together, you'd get 9y equals negative 45. Right? And so then you would have y equals negative 5. Okay? And then once you get y equals negative 5, you'd plug into one of these. So I would probably plug into row 2. So then we would get negative x minus 5 equals negative 13. So negative x equals, if I add 5, I get 8. Right, negative 8. So then x is 8, and so we have 8, negative 5, so then just go ahead and check. If I put an 8, 8 minus 13 is negative 5. Here we would get 40, and then minus 25. Ooh, that's not so great. That doesn't work out then. Oh, because I can't subtract. Here we would get 32 minus 25. 32 minus 25 is 7. Okay. Whew. Oh, I had to think way too hard on that one. Okay, so this is not my preferred method for this because y is solved for. I would prefer substitution. So we would have 4x plus 5, but instead of y, we would put x minus 13, and then that equals 7. So 4x plus 5x minus 65 equals 7. We get 9x. If I add 65, then I get 72. Yep, and then x equals 8. And then I would say y equals 8 minus 13 by plugging it back into here. So then y would be negative 5. And again, we get 8, negative 5 for our solution then. Okay, number 3, I would do elimination. For number 3, number 3 would be kind of a disaster to do substitution. Number 3, I'm only going to do elimination. So for number 3, we have twice row 1 plus row 2. So we're going to go negative 6x plus 10y equals negative 20. And then 6x minus 10y equals positive 20. Add those together, you get 0 equals 0. Okay, so at this point, once you get 0 equals 0, you know there's infinitely many solutions, so we have to solve. So I'm going to solve for the y here. So I get 5y equals 3x minus 10. Divide everything by 5. So y is 3/5 x minus 2. So because I solve for y, when I do set notation here, I'm going to have all the ordered pairs x, y such that x is all real numbers and y is 3/5 x minus 2. So that's one possible solution. Some of you might solve for x instead here. If you solved for x, you would get negative 3x equals negative 5y minus 10. And then you divide everything by negative 3, so 5/3 y plus 10/3. So your solution, had you solved for x instead, will be all the ordered pairs x, y such that x equals 5/3 y plus 10/3, and y is all real numbers. Okay, so only the purple, only the green. You're not going to be doing both of these here. All right, number 4, you can watch those videos separately. I did an elimination for x. All I did for number 4 here, I just put the 3 solutions for when you eliminate x. I did not show on paper here like which 2 to solve as a two variable system, so you can watch the videos for those. I didn't even do y. I'm hoping when you guys see this, everybody would have chosen x or z, so I just did both of those. All right, and then you have your solution for number 5. Oh, let's see how we want to do this one. So it looks like we have a line and we have a circle. And for this one, I would not do elimination because I don't even have an x squared, y squared in this first one. So I'm going to jump right to substitution. All right, so because of that, I'm going to be substituting this y into the y in row 2. All right, so I'm going to take the y from row 1 and sub into row 2. So I get x squared plus x minus 3 quantity squared equals 9. You need to be careful because this is really x minus 3 times x minus 3. So that's x squared plus x squared minus 6x plus 9, which equals 9. The 9s will cancel out. I get 2x squared minus 6x equals 0. I'm going to factor out a 2x. And the x minus 3 is 0. And therefore, x equals 0 and x equals 3. So we have our two x values. And what we need to do is we need to plug them in and solve for y. I'm going to plug them both into row 1 because row 1 I have y equals and it's really simple to solve for. So when we do that, I get for row 1, when x is 0, y is 0 minus 3. And then y equals, and then 3 minus 3. So that would be 0. So I get 0, negative 3, and I get 3, 0. Now, a couple of things here. I have a line and a circle, so I can have a maximum of 2 solutions. If you were to plug in 0 here, right, and then you're going to get y squared equals 9, so then you would get y equals plus or minus 3, right? So you would have 0, -3, and you would have 0, +3, but then you need to check, right? And if you had 0, +3, that would not work in row 1, that would be extraneous, okay? So do watch for that. So if you plugged into row 2, you would get 4 solutions, and 2 of them would be extraneous. All right, for number 6,